Hello dear students, hope you are doing well. Today we are studying a new video on solid state. This is part 2 of this chapter. So in this video we'll study crystal lattice and unit cell. And there are different types of crystal lattice. So first, what is meant by unit cell? Now unit cells, they are building blocks. Like you form a crystal. If you form a crystal by the repetition of a particle along the three axes, that is x, y and z. So say if you take this building block from here, and if you repeat that block again and again in 3 dimensions, you get crystal lattice. So unit cell is the smallest unit in a crystal, which when repeated in 3 dimensions, if you repeat in 3 dimensions, that is x, y and z, gives crystal lattice, is known as unit cell. Now crystal lattice is the solid formed by the repetition of unit cell. Now say for example, just a common example, is not actually related to unit cell and crystal lattice, but say textbook. Now in a textbook, you have many number of pages. Now the textbook, if you consider as crystal lattice, now the textbook is made up of many number of pages, so these pages you can consider as unit cell. So unit cell are the smallest particle, which when repeated in 3 dimensions gives crystal lattice. Now based on certain parameters, crystal lattice, they are classified in the following types. Now what are the parameters? Now if you arrange unit cell along three dimensions, that means x, y and z, so this is x-axis, y-axis and z-axis, x, y and z. Now the length along x, that means the unit cell arrangement along x-axis is up to length say a. So the length along x-axis is considered as a, along y-axis is considered as b, and along z-axis is considered as c. So that's how we get the length parameter a, b and c. So the length parameters are a, b, c. The angle between y and z is alpha. X and z, beta. X and y, gamma. So these are angle parameters, that is alpha, beta and gamma. So based on these parameters, crystal lattice are further classified into 7 types. Now if the length along x-axis is equal to the length along y-axis is equal to the length along z-axis, that means A equal to B equal to C. And if all the angles are equal and is equal to 90 degrees, the crystal lattice is known as cubic crystal lattice. Now, cubic crystal lattice are further classified into 3 types: simple, body and face, which we'll study later. Next is tetragonal. In case of tetragonal, A is equal to B, but is not equal to C. That means the length along x and y axis are equal, but is not equal to the length along z axis. Alpha equal to beta equal to gamma is equal to 90 degrees. Orthorhombic, A is not equal to B, is not equal to C. That means the lengths along x-axis, y-axis and z-axis all are different. Angle alpha is equal to beta is equal to gamma equal to 90 degrees. Hexagonal, A equal to B but not equal to C, alpha equal to beta. That means the angle alpha and beta will be equal to 90 degrees, but gamma is equal to 120 degrees. So you can see the parameters for different types of crystal lattice are different. So based on this, the classification is done. Now, for class 12, you have to study the cubic crystal lattice in detail. So let us start with cubic crystal lattice. Cubic crystal lattice. So in case of cubic crystal lattice, A is equal to B is equal to C. The length along X, Y and Z axis all equal. Alpha is equal to beta is equal to gamma is equal to 90 degrees. In cubic crystal lattice, we are going to study three different types of unit cells. They are simple cubic unit cell, which is also known as primitive unit cell. Next is body-centered unit cell. In short, is known as BCC. And face-centered unit cell, which is also known as FCC. Now, this classification is based on the atom, the presence of atom in the crystal lattice. Let us consider this as a cube. Now you can see in a cube we have 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corners. 1, 2, 3, 4, 5, and 6. There are 6 faces and one whole body. So there are 8 corners, 6 faces and one body. Now if we arrange the atoms only at the corners, if the atoms are present only at the corners, that means 8 corners are there. So if the atoms are only present at the corners, is known as simple cubic unit cell. If the atoms are present at the corners and faces, that means in addition to corners, the atoms will be also present at the faces, is known as face-centered cubic unit cell. And if the atoms are present at the corner and the body, then the unit cell is known as BCC, body-centered cubic unit cell. So very simple cubic unit cell, the atoms are present only at the corners. Face-centered cubic unit cell, the atoms are present at the corners plus the face. In case of body-centered cubic unit cell, the atoms are present at the corners plus in the body. So next, we'll calculate the total number of atoms in simple cubic unit cell, body-centered cubic unit cell and face-centered cubic unit cell. So calculation of total number of atoms. Total number of atoms. So number 1, we start with simple cubic unit cell. So since it's a simple cubic unit cell, the atoms are present only at the corners of the cube or edge. Now, this corner atom, each corner atom is shared by 8 unit cell. That means if you place an atom here at the corner or the edge, this atom, this particular atom will be shared by 8 unit cell. So if it is shared by 8 unit cell, the contribution of the atom to this unit cell is 1 by 8. Like if you have one apple and there are 2 people, what is the share? 1 by 2, 1 by 2. If there are 3, 1 by 3, 1 by 3, 1 by 3. So similarly here, this is shared by 8 unit cell. So each unit cell will get 1 by 8. That means we can say contribution from the corner atom is equal to, from each corner atom you'll get 1 by 8. Now similarly, from the rest of the corner atoms you'll get 1 by 8, 1 by 8, 1 by 8. So you'll get 1 by 8 multiplied by 8. So the contribution from the corner atom is equal to 1. Now in case of simple cubic unit cell, you have only corner atoms. So the total number of atoms is also equal to 1. So in simple cubic unit cell, the total number of atoms is equal to 1. Now let us see for body-centered cubic unit cell. Body-centered cubic unit cell. In short, is also known as BCC. Now, in case of body-centered cubic unit cell, there will be corner atoms. But in addition to the corner atoms, the atom will be also present inside the body. That means in the body. Now, contribution from the corner atoms. So we already know that contribution is 1 by 8 from each corner atom. There are 8 corner atoms. 1 by 8 multiplied by 8 is equal to 1. Now here we also have the body atom. Now if the atom is present in the body, it's not shared by any other unit cell. So the whole atom will belong to this particular unit cell. So the contribution from body atom is equal to 1. And since you have only one body atom, 1 multiplied by 1 is equal to 1. So now, the total number of atom in BCC is equal to 1 from corner. The contribution of corner atom is 1 plus contribution of body atom is 1. So the total number of atom is equal to 2. Next is face-centered cubic unit cell. Let us check the number of atoms in case of face-centered cubic unit cell. Now in case of face-centered cubic unit cell, the atoms will be present at the corner as well as the face. So you'll have 6 face atoms and 8 corner atoms. So contribution from corner atoms is equal to 1 by 8 multiplied by 8 equal to 1. Now contribution from face atom is equal to, now if the atom is present at the face, that means it will be present here at the center of the face. Say if this is a face, the atom will be present here at the center of the face. Now if the atom is a face atom, it is shared by one more unit cell. That means each face atom is shared by 2 unit cells. So the contribution from each face atom is 1 by 2. We have 6 face atoms, so it's 1 by 2 multiplied by 6, which is equal to 3. So you can see from corner you get 1, from face you get 3. So total number of atoms in face-centered FCC crystal lattice is equal to 1, that is from corner, and 3 from face. So total number of atoms is equal to 4. So in case of simple cubic, you have 1 atom. In case of body-centered cubic unit cell, you have 2 atoms. In case of face-centered cubic unit cell, you have 4 atoms. So in the next video, we'll study packing efficiency for different types of unit cell, like simple cubic unit cell, body-centered unit cell, and face-centered cubic unit cell. Thank you.